In this episode of the Exploring Information Security podcast, we explore the challenges of internal certificate management.
Computers now have primary control of critical functions.
Houston, recommend vector transfer.
Your go for APU shutdown on time.
Roger, go for deploy.
Nice to be in orbit.
Welcome to the Exploring Information Security podcast, where you will learn, explore, and grow your security mindset. I'm your host, Timothy D. Block. And in this episode, we will be exploring how to manage certificates in a development environment. With me to do that is Ben Burkert, co-founder and CTO of Anchor Security. Show notes can be found at exploresec.com/EIS. Feedback for the show, timothy.dblock@exploresec.com. You can also leave a comment on the website at the previous address that I just mentioned. You can also hit me up on LinkedIn. If you want to connect, just let me know you listen to the podcast and I will happily connect. You can also rate the podcast on your favorite podcast platform. That really helps grow the podcast and its reach and allows more people to find the great content here. So with that, this was a really great conversation with Ben about internal certificate management, kind of the ins and outs of it, and really what Anchor.Dev has done to really kind of help solve that problem. So if you want to check it out, I'd recommend going to Anchor.Dev. With that, we'll just kind of go ahead and get into it. Yeah. So, I mean, what was the origin of Anchor.Dev? Because I looked at your history and you've been in a bunch of different pretty big name companies doing, development work, but then also, I guess, dealing with like internal certificates, things like that.
Yeah. What was the origin? Kind of just experiencing the pains with internal CAs and managing internal CAs at companies, big and small. At Heroku, I worked on a lot of kind of the back-end networking, TLS encryption stuff. Dealt a lot with certificates. Another place I worked at was a CDN. They did a ton of stuff with certificates and TLS and encryption. They probably had more certificates provisioned than anyone, maybe other than ACME and some other CDNs. I was on a team with really great security engineers. They were building their own tools, like doing really cool stuff with encryption and TLS, and like most of the outages that we experienced were around managing the internal CAs and kind of just the operational mismanagement of those CAs. So that's kind of when it dawned on me that, like, hey, there's a real need for this technology because companies absolutely have to add internal encryption. And even the people who are writing the tools for this stuff are still experiencing these sort of like operational mismanagement issues. And, these, when these certificates expire, it causes outages, it causes business interruption. And they're usually like pretty embarrassing business interruptions because it's like, it's not like it's not like a scaling issue. It's not like we're trying new technology that no one's ever done. It's really just like forgetting to renew a certificate. It's kind of basic stuff. So the challenge there is really that there's so many certificates. It's so hard to keep track of all of these various certificates you've got spread out everywhere. So, it was a lot of just kind of experiencing the pains of internal certificate management at companies that kind of really clicked for me that there's this real need for better tooling, better products around this stuff.
Yeah, I mean, certificate outages are you're exactly, and you find out quick too. Like the next day, it's like, oh yeah, we forgot. And like the way I've been privy to, I love the automation of it because you feel like if you're doing it every year, and that makes it easy, right? And we'll get into kind of that, but it's usually like a calendar invite, and then but if that person left, the calendar, right, you got to have like multiple people. But that is to me kind of like archaic, and it's like it's not really a good idea. So if you can solve it automatically, you should.
Exactly. Yeah. A lot of companies still run off of that really important calendar that's, has all their really important certificates to remind them to renew it. And, it's not foolproof.
Yeah. So were you forced into certificates, or did you just like have an interest in certificates?
I would not say I have an interest in certificates. It's one of those like technology areas that is ubiquitous. It's like it's everywhere. I mean, we're having a conversation right now, and the reason it works, it's encrypted, is because certificates were used to make sure that we could trust each side of this conversation. It's everywhere, but like no one really wants to touch it or deal with it because it's just gnarly technology. And I've kind of just for whatever reason, I tend to gravitate towards like the stuff that doesn't get a lot of daylight shined on it. And so I wouldn't say I enjoy dealing with X509 or certificates and kind of all these things, but I think there's just a real need for it because it's so important. And there's really, compared to kind of everything else in technology, I feel it's kind of like underserved in terms of like eyeballs and attention.
Yeah. So I'm with you. Like, that's what I tell people. I like some of the other stuff, but like, and I have a basic understanding of it, right? You probably have a way better understanding of it I do, but I have like a basic understanding of certificates, Alice and Bob and all this other stuff. But when you get into it, it can get super complicated and it's super easy to screw up at the same time.
Exactly. Super complicated, easy to screw up. And it's also, the thing about this certificates in particular is like, this is all open standards, but these standards started in the 80s and they've kind of just evolved since then. And they haven't evolved very gracefully. So you're dealing with a lot of cruft that's just accumulated over the last 30 plus years. I mean, certificates, when they were originally envisioned, when the X509 standard was created, the internet was a thing. Web browsers weren't a thing. The first web browser hadn't been written. So there was never any intention for certificates to kind of be this underpinning of the kind of global information system that they ended up being. So they're really kind of just, they got shoehorned into the internet 30 years ago, and we've been kind of just duct tape bringing them along ever since. And they're so critical. It's pretty crazy when you think about it.
Yeah. Without going, I guess, too deep into it, like what is a certificate?
A certificate is a document that is verifiable, that lets you basically prove to somebody else some sort of information. For example, domain name. I can prove to you that I own my own domain name, benburkert.com, with a certificate, and you can take that certificate, check it using public key encryption, verify the signature that I have on it, and basically be confident that I am who I say I am because I've presented you this certificate.
Yeah, I mean, I think about oftentimes when we're talking about this kind of stuff, right? I like to think about stuff before the internet. So like exactly like the Enigma cracking machine. That was the Germans had a very strong encryption, essentially, which was a set of codes or numbers that encrypted all of their communication. And I feel like this is just a lot of the same stuff.
Absolutely, yeah. It definitely, it all evolved from the same. I heard someone say the cryptography is the science of secrets, and all of this stuff is related. It all evolved. A lot of it dates back to Bletchley Park and what the Allies were doing, and it's got an interesting history for sure.
So within certificates, though, we've got like things like TLS and SSL. Can you kind of explain that real quick?
Sure. TLS is the protocol that your web browser uses, that your email client uses to establish a secure channel between itself, the client, and server. So if you think of TCP/IP, your phone or whatever, it's a client. It sends internet packets out. TLS is a layer on top of that IP layer that adds encryption. And the way it is able to do that is uses a couple protocols, or it is a protocol. It uses a couple standards. One of those being X509. X509 is a standard which describes basically a document. That document is a certificate, and this document has some information that it wants to convey, and then a signature that kind of verifies that you can use to verify that signature. So whenever you establish a TLS connection, what kind of ends up happening first is you first set up a TCP/IP connection, and then you layer on top of that a TCP connection. And the very beginning of that connection, the server and the client exchange some kind of metadata information. The client says, "Hey, I want to talk to, Google.com," and Google will send back, "Hey, I'm Google. Here's the certificate that I have that proves that I'm Google." The client will then kind of look at that certificate, do what's called walking the chain of trust. It will match that certificate to a known set of good certificates to make sure that that certificate was issued by one of the CAs that the browser or your phone trusts. Once it verifies that signature, it says, "Okay, this other end that I'm talking to is Google. So I'm going to create some temporary encryption keys, and then I'm going to use those keys for this session, and I'm going to send it back to the other side so that the other side kind of receives those keys." It does this using a cool encryption trick called Diffie-Hellman, so that even if there's someone in the middle intercepting this, they can't actually see the contents of those keys. So both sides agree to using Diffie-Hellman, they agree to the same shared key. At that point, they can use symmetric encryption. The TLS is this cool way of both proving that you're the server that you say you are, and then also creating a encrypted channel that can't be tampered with or hijacked by like a man in the middle attack. So it's kind of crazy that it all works. Cool.
I mean, you threw out probably a bunch of words that we could really dive into. We're not going to dive into. If anybody wants to dive into those words, they can go Google a lot. Put this audio into Chat GPT and let it explain some of these other concepts. But one thing I do want to talk about is the CA, which is the certificate authority, and kind of just explaining, because I think that's a very important piece of infrastructure.
Oh, absolutely. Yeah. That's kind of the operational piece that makes all of this possible. It's possible. So another protocol, SSH, protocol for logging into servers, it works without certificates, but it gives you kind of the same equivalent secure channel. It can't be tampered with. It can't be man in the middled. But the way SSH is different than TLS is that with SSH, you have to pre-distribute keys to the endpoints that you're going to connect to. You're probably familiar with like uploading your SSH key and like catting it to a known host file or something like that, or the other way around. That you don't do that with TLS. You don't when you want to go to like randomcatpictures.com and you've never been there before, you don't have to like out of band like call them up on the phone and ask them for their host key or anything like that. So how is TLS able to allow two sides to establish a secure connection without actually having talked or exchanged any information before? So the way that's possible is with what's called chain of trust. And this is where CAs come in. So chain of trust allows you to kind of walk the steps, walk cryptographic signatures back up to a known good root, or sometimes called an anchor. And so the way certificates work on the public web is on my domain, benburkert.com, I use a CA to issue me a certificate. That CA is Let's Encrypt. So Let's Encrypt has a root certificate. It's called a self-signed certificate because Let's Encrypt generated a key. They stored it in a very secure place. They took that key and they signed a certificate that says, "I am Let's Encrypt." And then they also took that key and issued what's called intermediate certificates. Those intermediate certificates are online. So they've already started building a hierarchy. So you have this root CA certificate at the top, and then intermediate certificates underneath that. And then those intermediate certificates are accessible via their API. So at some point, I used a ACME client to request a certificate for my domain. I used like a DNS challenge to prove that I own the domain that I own. And then Let's Encrypt kind of validated that challenge and then used one of their intermediate certificates or intermediate keys to issue me a end user certificate. So you have this kind of 3-tier hierarchy that's going on. You've got the root or the anchor at the top, and then this intermediate, and then my end user certificate. So that's the certificate that when you connect to my website, that my website presents to you. And so what happens on the other end, on your browser side, is you get back this certificate, and it's going to contain an intermediate along with it. And then your browser has already been bundled and already has the Let's Encrypt root certificates public portion inside of it. So your browser trusts Let's Encrypt, and I'm saying, here's a certificate that's been signed by Let's Encrypt. So it's not that you trust that I am who I say I am. You trust that Let's Encrypt says that I am who I am. I think that's right. So it's so walking that chain of trust is done by cryptographically verifying each signature along the way. First you verify the signature of the end user leaf certificate, and then the intermediate certificate, and then that root CA certificate. And that's done every single time. Anything, every time you go to a new website. So it's super fast. It's easy to do, and pretty cool stuff.
It's no wonder people forget to do this stuff. My stuff gets taken out, but like to your point earlier, right? It's no wonder that like this actually all works because it's very, and it keeps getting more. I feel like it's getting more and more complicated because I mean people have new techniques of cracking it. Like going back to the Allies crack the Enigma decrypt, and that's why we have TLS 1. Before TLS, right? It was SSL. Right. If anybody remembers Heartbleed. That was a cool one to see. And then it's like, yeah, we can't really fix this. So go to TLS, go to TLS 1. 1.1. And now we've got like 1.3. And I imagine we'll get 1.4 at some point.
Yeah. And I think it's amazing to see like TLS evolving and changing. There's also new standards coming out, like the post-quantum stuff. I think NIST just like released their final draft. So even if like the TLS protocol itself doesn't evolve much in the next couple of years, I think it still will. You're still going to see, you're going to see new algorithms and new signing mechanisms to kind of protect us against those post-quantum potential attacks in the future. So, this stuff is going to start changing faster and faster, I think.
Oh, yeah. Yeah. Glad I don't have to deal with it other than having to remember to do my certs. But I do the same thing too with like my website where it's all through Let's Encrypt and it just automatically gets taken care of. So I'm one of those people. So you mentioned anchors as far as the certificate authority. Is that kind of where the name Anchor.Dev came from?
It is, yeah. It comes from that. Also, co-founder and I lived in San Francisco in a neighborhood called Potrero Hill, and there's a brewery there called Anchor Beer. And we used to like smell the wort as it was being brewed every day. So it's kind of both a call out to the root of trust, Anchor, and then also our roots in San Francisco.
Beer. Did you go to the brewery a lot, or you just smelt it a lot?
I ended up going quite a bit. I lived down the street for a couple of years, and it was pretty cool. They also had this cool tour that you could go on, and this place was crazy. They had these like old German not vats, but like the big copper pots where they actually brew the beer in. They like, I don't know how, they must have like shipped them from Germany in the, I don't know, turn of the century or something. And it was just like really impressive to see their operation. Yeah. Pretty cool stuff.
No, that's cool. I actually have a pizza place near me that did the same thing where they went over to Italy and then they brought, it's all wood fire pizza, which is phenomenal.
Nice.
I love breweries too. So if I'm in San Francisco, I'll definitely have to check out Anchor Brewery.
Oh yeah, definitely try and catch the tour. It's definitely worth it. Pizza and beer, it's a great combo.
Yeah, you also mentioned ACME client. So despite me being in application security, I've never heard of ACME client. So what is that?
Oh, sure. Yeah. ACME, there are many ACME clients. Kind of the biggest one is one created by the Let's Encrypt folks called CertBot. ACME is a RFC standardized protocol It describes an API that you can implement that allows you to prove A, that you own a domain, and then B, issue a certificate for that domain. So the way it kind of got started was back in 2014 or 15 when Let's Encrypt got started. They really wanted to. Before that, we had this problem of certificates. You had to get them through a CA private entity company. They were charging like $100 a certificate, sometimes more. And so the web was kind of lagging in terms of like HTTPS encryption adoption because people didn't want to pay. They didn't want to shell out, $100 to get a certificate that's going to expire in a year and, keep doing that. So Let's Encrypt said, hey, we think it's important that the web add encryption everywhere. We think it's important for privacy, for, many reasons. And one of the barriers is the CAs are just charging too much money for these certificates. So let's give away certificates for free. So in order to give away certificates for free, they had to fully automate the process. They couldn't be any kind of manual steps involved. So they started building this ACME protocol. And they were kind of the first implementation and, a major voice in the creation of this standard. It's since been ratified as like an RFC standard. And so it's like a RESTful API. Anybody can implement one. Anchor, we've implemented one. Let's Encrypt has one. Zero SSL. There's a couple other public CAs that provide, ACME endpoints. So you can take one of your ACME clients and point it at one of these ACME providers or ACME servers and use that to provision a certificate for yourself. So it's kind of I would say it's the biggest kind of innovation that kind of unclogged the gears of like encryption adoption. It's been wildly successful. We've seen like a big spike in encryption on the internet since Let's Encrypt kind of created this stuff. And so, yeah, it's great technology.
Yeah. So, I mean, to me, it's kind of like, so it sounds like it's like automating some of the certificate stuff, right? And that's
why you can automate it.
And that's why Let's Encrypt is so popular too among a lot of people, is because it automated a lot of what you're talking about especially for personal websites. Because I know when I got into it, it definitely was like hey, you got to pay for this, and then you got to remember to actually do it on your own personal website. Whereas, like I said, Let's Encrypt, it just does it for me now, and I don't have to worry about it. Exactly.
Yeah. Mm-hmm. And they've actually shortened the lifetime of those certificates. So they'll give you a certificate for like 45 days, which sounds like it's worse, but it's actually a lot better from a security perspective. Yep. Certificates are hard to revoke. So moving to short-lived certificates is a big win security-wise.
Yeah, I definitely feel like I see that a lot more nowadays, especially now with, because I mean, the whole point of this is to keep attackers out and from reading, transmissions and stuff. I'm starting to see like sessions are being stolen. So being able to reduce the time alive for a lot of this stuff. Certificates is a much longer, it's got a much longer lifespan, but still, like to your point, it used to be a year, potentially, 5, 6, 7 years. But they're like, oh wait, we can't expire these now. Cause but yeah, getting to a shorter time. Absolutely. Right. So is that kind of like along the path? So I feel like we've progressed to like, this is what Anchor does or what does Anchor actually do?
A little bit. Let's Encrypt provides public certificates. So web PKI certificates, certificates that are trusted by browsers. TLS works both kind of with public web PKI or public CAs, but also with internal CAs. You can build and manage your own internal CA, issue certificates that aren't going to be trusted by anyone but your internal organization. This is a popular thing to do for people wanting to add application encryption. I've got a service A that talks to service B, or service B that talks to a database, or maybe I've got some components that are running outside my VPC and some other deployment. There's a lot of reasons to add encryption to your internal network. And there's many ways to do that. The best way we've found is that TLS, it works on the web. It works great on the web. It also works great inside your internal network. It's the certificate management that's the real problem when you try to deploy TLS internally. So Anchor provides kind of the same experience that you get from Let's Encrypt with your public certificates. We provide that same experience with internal CAs. So we build and manage an entire CA just for your organization, or multiple CAs if you want to like have a CA for your staging environment and a different one for your production environment, so that you can't really get those like cross-contaminated anyway. And the idea is that Anchor removes a lot of like the toil that goes along with dealing with CAs. So doing like automated renewals. We actually build language packages. One of the big problems with internal CAs is that you've kind of got two problems. You've got the provisioning problem, which is getting certificates onto servers. And then you have the distribution problem, which is like getting all of your clients to trust those certificates that are being presented by servers. So that's something that the browser and the operating system vendors do for you on the public web. You don't even really notice that you get like a new CA update. But for internal organizations, they have to do all that manually. So that's the real pain point of internal TLS. So we build language packages, OS packages that let you install those chains of trust into your clients, so that you don't have connection issues, or you don't have to deal with like certificate stores on these certificate stores. They're like usually file based. There's not really like a good standard or protocol for them, so they're kind of gnarly to deal with, and it just ends up being painful. So that's kind of like the big difference between Let's Encrypt and like Anchor, is that we're solely focused on internal CAs and internal TLS deployments.
So is this another server that the company has to spin up, or is this a cloud service, or like how does that work?
Yeah, it's a cloud service. We run and manage it ourselves, and you can interact with it just like any other ACME server. Yeah, exactly.
And the focus is just on dealing with this internal problem. You're not dealing with all the browser and other stuff.
Right. We have built a tool called LCL Host. That's the domain LCL.host, that helps you kind of set up local HTTPS in your development environment. We basically took kind of the guts of Anchor and rewired them so that instead of a staging or production environment, we're giving you a CA that's dedicated for your development environment. So if you're like a front-end developer, software developer, and you are building a website and you like realize, oh, I've got CORS issues, or I'm dealing with like, let's say Apple Pay, and Apple Pay requires HTTPS. There's this like annoying thing where you have to like use localhost in your browser, but it's not really like HTTPS in production. So that when you deploy your app to production, things break because it's like, oh, this is HTTPS now, and like I'm not allowed to do that. Best way to bypass all that is to just use HTTPS in your local environment. There's definitely tools out there like MakeCert that allow you to build your own CA on your own machine. We LCL Host is more for teams. We will let you like set up your app, basically wire up ACME into your app, and then you use that ACME client in your app to get a certificate that works for your local development environment. And then everybody on your team kind of they're already ready to go. It's really easy for them to switch from like local host development to LCL Host and use HTTPS in their development environment.
Gotcha. Yeah. So yeah, that's what I was going to ask, is like, why should devs care about, encrypting dev? Because it's dev, right?
Yeah.
A lot of stuff. I was like, why aren't we doing the basics? It's dev. We're just
Oh yeah.
Point, it's like even for them, it's not even security, right? It's just making sure things work that work in dev are going to work up, as it gets pushed to the next level.
Bingo. It's all about that like dev prod parity.
Yep, exactly. Yeah, well, and that's what we talk about a lot, right? Even in security, we're the same way. It's like you guys should have your systems as close, because really, I want to come in and pen test on that stuff too. And if I see HTTP in an environment, I usually never test in dev. It's usually like staging. But if I can get even an environment that is going to be, even from a certificate standpoint, going to be the same, that's even better, because then I can test some of those connections.
Yeah, exactly.
So what are the prereqs or like recommendations before like a company or team wants to get Anchor? Like what do you feel like a dev team needs to be able to implement this?
we're really trying to make the product kind of available for developers who don't have a strong understanding of certificates or TLS, but they know that they need internal encryption. I kind of mentioned a few reasons before. There's some advantages to using TLS instead of just TCP/IP. For example, HTTP2 kind of mandates that you use TLS for an HTTP2 connection. There are frameworks like gRPC. gRPC is this like nice way of kind of abstracting, declaring APIs and then like interacting with them. Pretty popular. I think it came out of Google, and it uses some of the features of HTTP2 that are not in HTTP1. You can do things like bidirectional streaming, which is really cool. You can actually have a server start. Well, I'll take this back. With HTTP1, you have this request response kind of paradigm where the client sends a request and the server sends a response. With HTTP2, you can actually start kind of interleaving those so that the server can start responding while still receiving the request from the client. And gRPC takes advantage of this. So you can do streaming where you can like send little messages to the server and it can send messages back to you, and it's still all over HTTP. And it works very nicely. To do that, you really need to deploy TLS to be able to use HTTP2. So there's a couple protocol reasons. Really, it comes down to there's this kind of big movement towards zero trust out there. Kind of the idea of it's no longer good enough to have one kind of security factor. You can't get away with just having like a VPN protecting everything in your network. You really need to start layering security now. You still need your VPNs. You still need your full disk encryption kind of at the infrastructure layer. You need to start thinking about JWTs and KeyPass and kind of at the top layer, at the account security layer. You need to have good short-lived credentials, those sorts of things. And then there's this kind of middle layer, which is like the service-to-service layer. If somebody gets on your network, you don't want them to be able to just talk to your database or talk to your service over here. So it's really security-wise, we're moving to a world where you need to start having kind of authentication and security at the kind of service-to-service layer. And so TLS, internal TLS is a good way of providing that. You can use certificates to on both the client and the server side, so that when a client talks to a server, the client is identifying itself and saying, hey, I'm this internal client, and here's the certificate to prove that I am. That way, if someone's on your network, they might be able to like get an IP connection to an internal service, but they can't actually kind of pass that authentication. So, that's kind of where the world is moving, but TLS is kind of a beast to deploy internally because of all the certificate management. So we're really trying to focus on companies that would benefit from adding encryption, which, hopefully is a lot of people, but don't really have that kind of like team on staff that can really properly manage and run an internal CA, because finding people to run internal CAs competently is like hard to do. They're in short supply. The tooling is pretty bad. So there's not a lot of people who like deeply understand this stuff, but it's super critical. So we're trying to kind of fill the need for those folks for smaller to mid-sized companies.
Yeah, so it's like a side thing for a lot of people. So like, do these companies need an internal CA already, or if there's not one set up, you guys can come in and take care of that?
We can come in and take care of that. I'd like to get to the point where we can kind of import people's CA certificates. That is something you can do. We don't support it yet, so we only really support kind of our own brand new. We build a new CA for you. The idea is that ACME is kind of our language, our API, our interface. So if you're already using ACME, a lot of people use Let's Encrypt in their backend to get certificates on their backend, and there's some problems with that. But we really try to be like a drop-in replacement, so that if you're using public certificates through a public CA, you can kind of just repoint your clients at us and use one of our internal CAs.
Gotcha. And you wouldn't, and I'm trying to think through this, you wouldn't be collecting any sort of data. You're just handling the certificate. So nothing's actually going out to your infrastructure. Yeah.
Okay. Yeah. And that's an important point. we're not actually in kind of the hot path of these connection setups. So when service A is talking to service B, they're not pinging Anchor to say, hey, is it okay if I can talk to that other service? Because of kind of the magic of certificates, they're allowed to establish a secure connection without like talking to like a centralized third party to say, hey, you guys are blessed, you can go ahead and do this. So that means that if we have outages, we're not actually, your uptime is not dependent on our uptime. You could still operate even if like we're not available during a short outage to issue certificates.
Gotcha. Okay. Yeah, that's very important too, especially like in this point, CrowdStrike, right? I'm sure you heard about that one. You don't want to be, don't want to be like CrowdStrike that starts taking down businesses. So it's good that you guys have some resiliency in there.
Right. Yeah, and it's nothing that we built into it. I mean, it was built into TLS because the internet just would not work if everyone had to like phone home in order to talk to anybody else.
Gotcha. Yeah. Okay, cool. Well, it sounds really interesting. Sounds like you guys are trying to tackle something that is a pain in the ass to a lot of teams. Like I said, I've seen it where it's just like, oh yeah, the server team, or if you're lucky that developers have their own DevOps or platform engineering team, they typically but it's like a small piece of it. I've been at a couple.
Totally.
Like, oh yeah, we've got an entire and you almost kind of need one, right? All right, cool, Ben. Well, thank you for joining me to discuss essentially certificate management. It sounds like you guys are doing a lot of great work over at Anchor.Dev.
Thanks. Yeah, thanks for having me on. Appreciate it.